What we've done in the last few videos is to get an overview of Gauss-Legendre Quadrature, quadrature being simply a fancy schmancy word for approximating a definite integral, and we derived this formula here for approximating the integral of f between a and b with the knowledge of 2 points. What we want to do in this video is to forget everything rigorous, difficult, or complicated that we've done in the last few videos and try to come up with this formula, or at least something very similar to this formula, just by combining two very simple methods of approximating an integral. So I have drawn 3 curves here. Rather, I have drawn one curve 3 times, and I want to estimate the integral using 3 different methods. 1, the midpoint rule, 1, the trapezoid rule, and 1, a certain mixture that we will be coming up with. So as you may know, the midpoint rule is rather simple. You just need 1 point on the curve, f of a plus b over 2, a plus b over 2 being, of course, just the midpoint of the integral. And that gives us a certain rectangle of which we can take the area by multiplying the width times the height. A simple rule, but also in this case at least not very exact. That is a gross underestimation of the integral since we're missing these 2 parts. So that's an underestimate. Of course, that doesn't have to be the case for any arbitrary curve, but let's just take that for what it's worth and look at the trapezoid rule. So the trapezoid rule, as you may know, just computes f of a and f of b and connects these 2 points, visually speaking, with a line segment, thereby constructing a trapezoid of which we can take the area by multiplying the width times the average height. And the average height is, in this case, just 1/2 of f of a plus f of b. And again, this is a pretty simple estimate, and that shows in the fact that we are grossly overestimating because we're counting this entire region here, which should not be part of the integral. So now we are overestimating. So how would it be if we just did something in the middle? Instead of taking this and this, so f of a and f of b, and instead of taking f of a plus b over 2, why don't we just take this point here, or at least somewhere close to that, maybe this point here or this point here. If we did that, at least let's just take this point here in the middle, and this point is pretty close to the middle, and we'll connect those points with a line segment here. Well, here we are again underestimating, and we're underestimating here, but we're overestimating here, and maybe that'll cancel itself out if we choose the right point, which seems to be somewhere near here. That seems to be canceling itself out pretty well, maybe not exactly. So how could we write that out? Let's invent a new rule. Let's call it maybe B for better rule, and we will just multiply again the width times, now we had 2 points here, right? we had this point there and this point there, so we'll just be averaging 2 points again, averaging f of something plus f of something else. And what is it that we would be averaging? Well, let's start at the midpoint. Let's say we have a plus b over 2. And it's not exactly clear yet. Maybe we'll still make a decision about that. Not exactly clear how much we want to go back from the midpoint and go forward from the midpoint. But let's start from the midpoint and go back just some amount. Let's call it s for sum. And maybe we'll go forward some, right? And maybe we can say something a little more about s. We definitely don't want s to be 0, right? Because if s is 0, then we're stuck with the midpoint again. And we also don't want s, the amount that we go forward here definitely should not be so far that we get to b again, right? So we want s to be less than this distance here. So what would this distance be? Well, the whole thing would be b minus a, so this must be just b minus a over 2, right? So that's sort of like the maximum distance that we would ever want to go. So s definitely needs to be less than this maximum distance, b minus a over 2, and it definitely needs to be bigger than 0. So let's continue here and rewrite this and maybe make a decision or two about how to proceed. So we're starting at the midpoint and we're going back some amount. We don't quite want to go this entire maximum amount, but we do want to go some sort of percentage of that way. What is that percentage? Maybe it's 50%, maybe it's 60% or 40 or something. So let's just write a p in there. Some percentage of this maximum amount we want to go backwards. And we also want to go forwards, and just take those 2 points. Okay, and we'll do the same thing here. In this case, we'll just say a plus b over 2 plus some percentage times b over b minus a over 2. And what could we say about p? Well, just translating this into percentages, we would say that p should definitely be more than 0, right? Because if p were 0%, then this whole thing would be 0 and we'd be stuck with the middle point again. So it should be greater than 0 and less than 100%, probably, or definitely should be less than 100%. Because if we took 100% of this maximum, then again we'd be over here at this point b, so we don't, or back at the point a. So we don't want that. So let's continue and rewrite again and maybe decide what sort of percentage we want that to be. I think going about halfway would be a good decision. So why don't we just call this 50%? 50% of the maximum. It seemed to work rather well in our example there. And again, we start at the middle point and then go forward 50% of this maximum value that we could be going forward. So that's our rule. We'll call that b. That's our better rule. Now let's go back and copy this original formula that we had and see if there are any similarities between this original formula and our new b formula. So I see one similarity, that both of them start with a b minus a, either divided by 2 or somehow multiplied by a half, right? So that makes them look a little more different than they actually are. right? The fact that I am here multiplying by a half and here dividing by 2. So why don't we try this? I will rewrite our Gauss-Legendre rule of estimating the integral of f from a to b with a knowledge of 2 points. And I'll try to rewrite it in a way that resembles our new formula, which was really simple. Just going halfway back from the midpoint. So let's start with b minus a times 1/2, because that looks a lot more like this. And then we're taking two function values. Okay, now this argument here looks a lot different than this, doesn't it? But if we look closely, we see here b plus a over 2 is the same as a plus b over 2, right? So let's just rewrite that as a plus b over 2. That's just the midpoint. A plus b over 2. And what else do we see? What are the sort of similarities? Well, here we have a b minus a over 2, and here we have a b minus a over 2. So we will still need to remember the square root of 3 that's still there, but we can go ahead and write that in. So that's b minus a over 2 was just the maximum amount that we wanted to go back. And then we'll have to write in the square root of 3, so that's just times 1 over the square root of 3. And for this parentheses, we don't see our b minus a over 2, but we do see an a minus b over 2, so if we just subtracted instead of added, then we would have our b minus a over 2. And we shouldn't forget about our square root of 3, so 1 over the square root of 3. And now we have something very, very similar to our new b rule. I think the only difference, actually let's copy this real quick. The only difference that I really see between our new b rule here, right here, and the newly written version of our g rule, the only difference that I see is that here we wrote 50%, and here we have 1 over the square root of 3. Well, let's see what 1 over the square root of 3 actually is. So 1 over the square root of 3, if we type that into our handy calculator here, we get the answer approximately 0.58, which is 58%. So why don't I go ahead and write that in there? That's just 58%. So, by looking very simply at the midpoint rule and the trapezoid rule and just mixing them, we came up with this rule here, where we just took two function values starting at the midpoint and went 50% back or 50% forwards to the ends of the interval, and we basically came up with the same rule as Gauss-Legendre. It's just that Gauss-Legendre is 58% instead of 50%. And of course, we wouldn't want to round that to 58% because it's really 57.7 something percent, right? So if you want to remember the rule, obviously you'd still want to be remembering this one. But if you think about it in this way, I think you'll find that it's a lot easier to remember than this version here that we had at the beginning. So if you're wanting to play that game that we talked about in the first video by giving someone the challenge of saying, yeah, think of some function, some polynomial up to degree 3, and I promise that if you just give me 2 points of my choosing, then I'll be able to exactly compute that integral. Then you might have a little more fun playing this game if you can remember the formula. And if you think about it like we've talked about in this video, you should be able to remember it without memorizing it, but just remembering it because it seemed to make sense that it would be that way. And it's pretty close to a very simple way of being.